we are looking at equations of lines in 3D. And here are some of the things I want to cover. How to find the equation of a line joining P to Q. We done one of those yesterday. How to find the equation of a line when you're told some information like it's parallel to another line. How to find the equation of a line if you're told it's, say, the intersection of two planes, right? Where two planes intersect, there's a line. And then suppose I give you the equation of two lines. How do you tell if they're parallel, skew, or identical? Right, that's the last part. So hopefully we can jump right into that. I did mention, I'm sure I did, I remember doing it, that equations of lines are not unique. And I just hope to God that WebAssign is clever enough to know that Kira's equation of a line, although it's different from Margaret's equation of the line, is the same line, right? Because if you choose a different point or you choose a slightly different direction vector, you know, make it twice as big, the equations all get kind of jumbled, you know, get changed. If you think that you've actually done the equation of the line correctly, you just can't get WebAssign to accept it. Tell me what your equation of your line should be. I will go in and I'll just give you the points, right? So that'll be it. So don't freak out if that happens. I'm just fingers crossed that WebAssign can do it, because sometimes it's really clever, isn't it? Sometimes it can actually handle that. And other times, I only want this. I don't care. It has to be this. So suppose I give you the point P and another point Q, and I want to find the equation of a line joining P to Q. So imagine that's P, over here is Q, I want that guy. If you get a question like this, make that the first guy, make that the second guy, at least we'll all be doing the same answer that way. And we need two things, one of which we've already got, which is a point on the line, and I'm picking P, and the other is a direction vector, which I call V, and the direction vector is the vector from P to Q. And 7 take away 1 gets you 6, 5 take away nothing gets you 5, and 3 take away 2 gets you 1. And I'm going to do the equation of the line using space curve, which is this fella. And it's really just a matter of putting the pieces together. So if we call this guy X1, Y1, Z1, and I call this guy, say, ABC, it's X1 plus AT, Y1 plus BT, and Z1 plus CT. And we have 1 plus 6T. We have nothing plus 5T. And we have 2 plus a T. And that's the equation. Now I do know, because I've actually recollect saying this, that WebAssign does this. And you fill in your answer with curved brackets. Technically, it's a space curve, so this is a position vector. It's not a big deal, but just in case you don't put the curved in and you put these in and WebAssign says you're wrong because it's been a pain. That is the equation of my line. Now, if I wanted to, I could write it down in vector notation, which would be that guy, oops, plus this guy, T. You comfortable with this is the same thing as that, right? I'm just separating out that point. Where is my point? 105, 102, what am I doing? There we go. I'm separating out my point and my direction vector times T. And you sometimes get it where you write it down in what's called its symmetric form. So this is vector form. If you want symmetric form, it's going to be that guy. So it would be x take away 1 over 6, y take away 0 over 5, z take away 2 over 1. And that would be the same thing as this, which is the same thing as that, right? They're all equations of the line. That is a space curve version. That's it written down in vector notation. And this is it in its symmetric form. Because they do ask you in different questions to write the equation of the line in one of these 3 ways. So just so you get used to it. I always do this one, and then I write down whatever they want if it's not this one. That's just the way my brain works. So go for that one first and then figure out if you need to change it later. Are we good with any point P to any other point Q equation of the line? Right. So we'll cross that off my little list. Right. Suppose I want to find the equation of the lines. And it has to be parallel to this line. I'll call it S of t then. I'll write it down here. Passing through the point 5, 0, -1. So I want to find the equation of a line parallel to this line and passing through this point. So can you imagine that this is the line S of t, right? That's this line here. And I've got a point here, P, and my line has to be parallel to this one, but passing through P. So you see my line would be the red one, right? There is enough information to get the equation of the line because there's only 2 things you need. I need a point on the line. Well, that was given to me for free. And I need a direction vector. I need to know the direction vector for my red line. All I'm told is that it's parallel to this vector. But if you know how to read the information that's stored here, shouldn't you be able to tell me the direction vector for this vector? Right, what is the direction vector for S of t?
3, 4, 0.
Or, look again. Where do the numbers that tell you the direction live? Do they live here or do they live next to the t?
It would be 2, -1, 5.
You see? You see? I bring this guy back. Remember this one? 6, 5, 1. Can you remember 6, 5, 1 was the direction vector? 6, 5, 1 are the coefficients of the t. So I now have a direction vector. Now you might say, well, what does the 3, 4, 0 tell me? Isn't 3, 4, 0 telling me that this line passes through the point 3, 4, 0, right? It tells me, you know, a point on that line, just one specific. Right, you put these together, you will get 5 plus 2t. This guy is nothing minus 1t, and -1 plus 5t. And we are done. Are we okay with that? You comfortable about how I can look at this equation and tell what direction the line is going? Random, put another one in. Here's a different guy. What is the direction vector or a direction vector for this line? Anybody? What's the direction vector for this fellow?
Is it 1, -3, 4?
Right? One of these, -3 of these, 4 of those. We comfortable now how you read it? If you give me the equation of a line, I can tell you pretty quickly what the direction of that line is in. It's not quite the same as a slope. Isn't a slope a 2D thing, right? And this is a direction, it's a 3D thing. It's close, but not the same. Are we good with a question that if I tell you a point and that it's parallel to another line, do you feel comfortable you could get the equation of this line? If you want another one, or are we good to move on for that? Okay, don't hear any dissension. Number 3 is a pain in the butt. A plane is a flat piece of paper, right? Sloping in 3D space, that's what we call it, right? Equations of planes have this format. It's an example. Now, if you take a second plane in 3D space, and you got to remember that this is how you draw them, but in real life, don't these planes go forever, right? They're not little rectangle strips, they're forever. But what would happen if one plane interacts, right, intersects with a second plane? Well, what typically happens is that you get a straight line. Does that make sense? If you took one piece of paper and another and you cut them, right, you found out where they met, wouldn't they meet in a line? So our job is to find the equation of that line. So that's what I mean by find the equation of a plane, the intersection of two planes. Now we'll make the assumption that these two planes intersect on a line, right? We're making that assumption, but technically there is another possibility. Couldn't the two planes be parallel to each other? Right. In which case there would never be a line of intersection, right? But if that was the case, I don't think it would be a fair question, right? Find the equation of a line that's not there doesn't sound to me to be a fair question, right? So we will assume that if they give you a question like this, that in fact the line does exist, and so we should be able to get it. And this one is not as clean as the other two examples. The other two examples, once you've seen one of them, you've kind of seen all of them. There's not an awful lot of things that could be different. So I'll pick one of their questions, and the reason I'm doing that is I want to make sure that I get nice numbers. If I just randomly pick two planes, you would get the ugliest numbers, you know, like 7/18ths and 45 112ths and yuck, right? So here goes. Question 9 wants to find the line that is the intersection of this plane with that plane. Okay. So can you imagine this is one of the planes, call that P1. And this is the second plane, we'll do it in green. So that's P2, P1. They're going to intersect on a line. That's what we're trying to get. I need two things. I need a point on the line. I don't care what the point is. I just need a point on that line, right? Any point will do. And secondly, I need a direction vector. Okay. And a direction vector, I'll call it V. We're coming back to this guy, but I have to show you a little side thing. When you write down the equation of a line, a plane, like this guy, these numbers here, 1, 2, and 3, they represent what's called the normal vector. The normal to a plane is a vector that has the property that it's perpendicular to the plane. So I'm going to try and use a piece of cardboard because it's a bit stiffer. Okay, imagine this is a plane, right? My pen is the normal. So if you turn this sideways, can you see, oops, there we go. Can you see that there is at right angles to the plane, right? And so I'm going to use that property to find the direction vector for this line. Because the line I want, which is this dotted line now, because I've changed my color scheme, won't this line, because it's in the plane, won't it be perpendicular to that normal? That makes sense? If I draw a line on the plane, right, this red line on the plane, won't it be perpendicular to this normal? Since this line is also on the second plane, won't it be perpendicular to the other guy's normal? So how's that going to help me? Well, the first one, this guy, has a normal 1, 2, 3. The second plane, that's this guy, has a normal 1, -1, 1. I want a vector perpendicular to this guy and perpendicular to this guy. What does that? What vector is perpendicular to these two? We've met this calculation before. What vector is perpendicular to n1 and n2?
The cross product.
Yep. When in doubt, just find the cross product. The chances are it's going to be the guy you want. So in this case, hope I've got enough room to squeeze it in. We have an I, we have a J, and we have a K. And the first one is 1, 2, 3. And the second one is 1, -1, 1. So that's going to be so many I's. Take away so many J's. My puppy has found her squeaky pig. I hear it. Right. 2 take away -3 gets you 5. 1 take away 3 gets you -2. And -1 take away 2 gets you -3. And so we are looking at 5, 2, -3. There's my direction vector. So we'll circle around it to remember that that's important. Are you comfortable that if I say find the equation of the intersection of two planes, that you'll find the cross product of the normals to the plane, right? 1, 2, 3, 1, -1, 1. And that will give me the direction of my line, right? So the next one is where it gets a bit vague. By that I mean, there's no particular way to do this. All I really need to do is to find one point that I know is on that line, okay? Just one point. So I have the equation of my line, which looks like this. And I have the other equation of my other plane, I should call them planes, looks like that. And I am going to do this. I am going to choose to make Z 0. I can't solve a system of equations when there's only 2 equations and 3 unknowns, right? I cannot do that. But if I make z 0, then x plus 2y will be 8, and won't x take away y also, in this case, be 8? And I can solve that system of equations, can't I? I could do it by the addition method. I could rearrange it and do a substitution method. I'm just going to multiply this guy here by 2. And what I now have is x plus 2y is 8, and 2x take away 2y equals 16. And when I add them, 3x gets me 24, and that gets me x equals 8. Now, once I know what x is, I can put x equals 8 into, say, this one. So 8 plus 2y is 8. So 2y is 0. So y is 0. Now I have a point. X is 0. Y is 0. Z is 0. Now you might think, why did you pick z equals 0? And the answer is because I felt like it. Could I have made y equals 0? Yep. Could I have made z equals 0? Yes. Would I end up with the same answer? Not necessarily. I would have got a point that's on the line, but I would have got a different point. If I really was being weird, couldn't I just make x 42? So you are going to have uniqueness here. Can you imagine that Joe looks at that and he says, I'm going to make y 0, and he goes and gets his answer, right? And Janice looks at it and says, I'm going to make z 0, and she gets her answer. Can you see that because those answers are going to have different starting points, aren't your equations going to be different? So see my little rant at the beginning today of, I hope WebAssign is clever. I think WebAssign has problems when there's an infinite number of points, right? So you might not quite find the one that it thinks is the right one, but you still could be correct. And we'll live with that. Okay, I got a point. I got a position vector. Put the package together and we're done. It's going to be 8 plus 5t, nothing plus 2t, and nothing minus 3t, and call it good. Are you comfortable about how to find the equation of a line that's formed by the intersection of 2 planes? Are you comfortable with this, what we did here? Are you okay with the randomness of this? Right?
Professor,
Yes, Jed.
I'm a little confused as to how, when you were like finding the x in this first part, how you got rid of the y in this equation.
Oh, I had 2 equations left over. So if you make z 0, can you see the 2 equations? These guys, wrote them down. And then I used a technique called the addition method from Math 94, which basically means that if you double everybody in this equation, you now have 2x, take away 2y is 16. And if you add equations together, which you're allowed to do, the x's join to get you 3x, but the y's kill each other off. And the 8 and the 16 gets you 24. So now I have an equation with just an unknown x, and that's how I got 8.
Oh, okay, got it. Thank you.
Right. Now, if you don't like that method because it's one that you're not comfortable with, couldn't you do what's called the substitution method or elimination method? I think it's another name for it. Can you rearrange this one and say y equals x minus 8, and then plug the y in here and solve for x? You still get the same answer, it's just a different approach. Do you want to see another one? Sorry, do you want to see another one like this, or are we good? I mean, they all look like this, they just do it with different numbers. Yes, you want to see one? No?
You do another one?
Another one, okay. I'm glad I picked theirs because do you see how nice the numbers are? I am now going to pick random, and random is scary. but I don't want to take the full responsibility. So somebody tell me how many X, Y's, and Z's and equal for my first one. And don't pick 244, because if you do, I'm going to make you solve it, not me. So I'm warning you right up the bat. Keep the numbers reasonable. Go for it. Just share it out, whoever feels like they want to tell me an equation. Come on, you wussies. How can you get this question wrong? I'm asking you to randomly pick some digits. There's no way in the world this is ever going to be wrong, right? Go for it. Come on.
5x, 8y, 7z equals 24.
Okay. And I'm going to take the second one then. X take away Y plus Z is nothing. I decided to go small, hoping that might compensate big, right? So we need two things here, don't we? We need to find the direction vector V, and we need to find any point in the universe that works for this guy, right? So I'm going to do what am I going to do? I'm going to do this fella first. The direction vector is the cross product of what's called the normals. This plane, the normals are the coefficient of X, Y, and Z. So it's going to be a 5, 8, 7 cross product with a 1, -1, 1. You happy about these coefficients get you the normal? These coefficients get you the norm. In this case, then, it's going to be an I, a J, and a K. 5, 8, 7, 1, -1, 1. Let's see what that looks like. So many I's, take away so many J's, plus so many K's. All right, cover that guy up. 8 take away -7 adds at 15. Middle one, 5 take away 7, -2. End one, -5 take away 8, -13. We have our direction vector. So far, so good. Right. Now we need to go hunting for a missing point, any point at all. This is not going to be pretty unless we get really lucky. But sometimes we do. What do you want? I tend to make one of them 0. Any particular preference? X, Y, or Z? I've got a preference right now. I know which one I'm picking. But is anybody else got a...
Y?
You want Y?
Yeah.
Okay. So we're going to be left with that, aren't we? Right. I'm going to do that because you asked me. Does anybody know which one I was going to pick?
The 7.
The Z's?
Yeah.
Yeah. Don't they play well together, those two? Right, they'd be a little bit easy to deal with, but that ain't my problem. Y equals 0 gets the job. So we've now got 5x plus 7z is 24. And we have an x plus a z equals 0. Now I'm going to do the addition method. And in the addition method, what you do is you basically pick x or y, and you want them to have the same amount, but one plus and one negative. And so I am going to take this equation here, and I'm going to multiply everybody by -5. So equation 1, I'm not going to touch. I'm going to multiply all of these guys by -5. So I get -5x, -5z equals nothing. And now I can add the equations together. And when you add these together, you get 2z. You add these together, you get 24. And you add these together and they kill each other off. And that gives me a very nice z. Hey, we dodged the bullet there. Z is 12. And now I'm going to put z equals 12 into that equation, or that one, or even that one. And I'm going to put it into that one. Because it looks to me like that would give me the nicest numbers. So we now have our point. Its x coordinate is -12, its y coordinate was 0, and its z coordinate was 12. Actually, since those numbers came out really nice, I think that was a good choice. Let's put the package together. Here is our direction vector, here is our point. So the equation of our line is going to be -12 plus 15t, 0 plus 2t, and 12 minus 13t.
The points we find can be different, correct?
Yeah. In fact, if you'd chosen, now I've seen her answer, I think hers is better. But if you'd went my road, wouldn't Z have been 0 and you would have got a totally different X, Y, Z because of that?
Yes, I
Because
got
in this,
24/13 for that, solving with Z equals 0.
what do you get with Z?
24/13 for X and Y.
Oh. Right. Which is what I would have expected in general. And just a really fortunate coincidence that these were nice. And can you imagine that that equation then is going to look different from this one, isn't it? Because the numbers that go here, here, and here are now going to be ugly fractions, and that one would be 0. Which makes WebAssign annoyed, but we'll live with that. I feel good about that. Do you feel comfortable about the intersection of 2 planes now? We move on? Great. Okay. So cross it off our list. Here is a relatively simple sounding question, which can be quite difficult to answer. So let's show you visually what can happen. I can have 2 vectors. I'm going to call them R and S. Okay. They can be parallel. In 3D world, parallel still exists. Can you imagine these 2 pens are parallel? You see it? 2 pens or 2 lines can be skewed. And that little dotted lines to try and show you what happens. Can you see that 2 lines, these are not parallel lines, would you agree? But they don't intersect either. Do you see there's a gap? And they never will intersect, right? So this is what we call parallel. This is what we called skewed. 2 lines could be identical. Couldn't they be the same line, one embedded in the other? In other words, there's my line. Put little arrows in my guys. And here's my other line. And they could be identical. If you think about how do 2 lines in 3-dimensional space behave, isn't one of these 3 going to be true? They're either parallel to each other, they totally miss each other, right? Okay.
If the 2 lines intersect, are they still called skewed?
Yes.
Okay.
That's just a special version of skewed, right? So what Kira's talking about, right? Here's skewed, right? You see there's a gap. But couldn't they intersect? But they're still skewed. Skewed is, I'm not parallel. How about that, right? And so that is a special case, right? Intersection. Now, if you're skewed, you might intersect, you might not. Okay, maybe that's part of the question they ask you, does it or does it not? And I'm going to find some examples of those. I know there are. Here we go. Where are you? There we are. An example of this would be question 15. And I don't like the way they've written the equation, but that's fine. We've got a line L1, and it's R of t. And I'm writing it down the way I prefer to write these, which is this bit. I like the space curve notation. And we've got another guy, I'm going to have to call it something, aren't I? It's going to have S in it, or in P of S. And it's going to be 4 plus 16S, 12 minus 8S, and 16 plus 20S. And we're being asked to choose between parallel and they are separating them out into parallel, skew, and intersect. I think this should be skewed, not intersect. And this should be skewed, intersect. Because both are skewed, they're just versions of it. But they don't want to call it that, so they're calling it parallel, skewed, and intersect. They are not allowing identical, so we'll not bother looking for that situation. So, if two lines, let's say this is R and this is S, or P, I should say. If they're parallel, how can we tell by looking at the equations of the lines? Because it is possible to do it. We just have to know where to look. So here's the equation of the first line, right? Now, if you look at what's told here, don't I know that this line passes through the point 12, 16, 4? Would you agree? And don't I know it has a direction 8, negative 4, 12? And similar kind of information here. So how am I going to tell if it's parallel? I am going to focus on the direction vectors. So the first direction vector, I'll call it V1, is 8, negative 4, 12. The other direction vector, right, this guy here, is 16, negative 8, and 20. If these two lines were parallel, wouldn't these vectors, one of them would be a multiple of the other? Great. One of them would be twice the size or half the size. So the test that we're going to do, and it's basically the first test that you try, is you take components and you basically divide them. A half, oh God, that's a 4, isn't it? So 3/5. Can you see? No match. So what I've managed to do is they are not parallel. If they were parallel, wouldn't this be a half, this would be a half, and that would be a half, because one of them's half the size of the other, right? So if you're going to be parallel, you need to be the same multiple each time, and you can check it by just doing a quick division. 8 with 16, second with the second, third with the third. If these fractions are the same, you're looking at parallel. If they're not the same, they're not parallel. So that's off my list. So I know it's skewed. Now I have to decide, is it intersecting or not? Right, if I can show that it intersects, I'll pick this answer. And if I can prove that they don't intersect, when I use this answer. So far, so good. Right. If I write down the x component of this line, it's 12 plus 8t. If I write down the x component of this line, it's 16 plus 16s. If these two lines intersect, shouldn't these be equal to each other? So what does that give me? It gives me an equation in x's and t's. If I say that this guy has to equal this one, I get a different equation. I get this fella has to equal that guy. And the z's should be equal, right? This should equal that. But I'm not going to use the z's yet. I am going to solve this set of equations here. And if you take this guy and, oh, don't know, subtract ht, subtract this one, what do you get? You get 16s, subtract 8t is equal to -4. And divide everybody by 4, because I like small numbers if I can get away with it. There we go. And that's going to be equation 1. And then if I take this fella and I try and, you know, why is one, well, that's a t. If I take these two, what can I get? If I bring this over, I'll get 8s. Bring that to -40 is equal to -4. And divide everybody by 4, I get 2s, take away t equals -1, call that equation 2. So I've taken these two and just made them a little bit prettier. Now I'm going to write them down next to each other. And what I'm going to do here is solve. I'm going to find out what S and T is, right? That's what we're going to do. Are we cool with that process? Do you want me to talk you through where all these guys came from and what I did? I set the X is equal, which is this. And then I just rearranged this information and then tidied it up. And then compared the Y's, got this equation. And then rearranged it and tidied it up to get that. Okay. Math 9499. I have a system of equations with 2 unknowns. Right? I'm going to use the addition method. I like the addition method. So I'm going to take this equation here, and I am going to multiply everybody by -2. And something weird's going to happen, I believe. So let's see what happens. Won't do anything to the first equation. And I'm going to get -4s plus 2t equals 2. And I'm going to add these together. And I get 0 equals 1. Right? All the s's kill each other off. All the t's killed each other off. Right? I'm ready to make a decision. Skewed or intersect? 1, Earth is 0 equaling 1 telling me. To me, it's telling me that's impossible. Agreed? What's impossible? It's impossible for these two lines to intersect, which means pick that one.
Wouldn't it be the one that's not intersect?
Yes. Oh, I picked the wrong one. I know what I said, I just checked the wrong one. Yeah, they don't intersect. Now, if I had got a solution, right, t equals 1, s equals 2, right? Let's suppose I did that, right? Suppose we managed to solve this, t equals 1, s equals 2. You're still no guarantee of an intersection. What you then do is you plug in t equals 1, you plug in s equals 2. If they end up being the same thing, they intersect, and that number that you just found is where they intersect. If you plug t equals 1 and say s equals 2, and you get 5, 8, 3, and 7, they don't intersect. If you get 5, 8, and 42s, they do intersect. So even if this works, it doesn't mean that they intersect. You have to do that final step of plugging in the t that's the solution and the S at the solution and see if they match up. There's a good chance they will, but they may not. Okay, how are we with that?
I just have a quick question.
Yes.
Can you show me where each of the pieces come from in the box in the upper right?
Yeah, right. I matched these two together. So 12 plus 8t is going to equal, where did that 16 come from?
That's what I was trying to figure out.
Oh, I just scanned. I'm doing my scanning thing. Well, yeah, now works for my new question. And they randomize these, so that could well be a question, right? So that's where that would come from. And then I got this fella, and I got that, right?
I'm good now. Thank you.
Okay, right. I don't have enough time to show you another question from scratch, but I will give you a start on the next one. And the reason I want to kind of zoom through this one is the way the question or the information that you're given is not very helpful for the process that you're going to use. You're being asked, is these two lines parallel, skewed, or intersecting, right? This is the symmetric form of two equations. I'll call this line L1, I'll call this line L2. This fella, if you rewrite it, x will be equal to 1t plus 3. The y will be equal to negative 2t plus 1. And the z will be equal to negative 3t plus 10. And you might say, well, how did you get these guys? And then turn that into the way I would prefer all lines to be written. How did I get, from here to here? Take this and pretend that it's equal to t. And if you solve this one, you will get negative 3t plus 10. If you solve this one in the middle, you'll get negative 2t plus 1. And if you solve this one equals t, you will get the t plus 3. You're comfortable about where that came from? That from symmetric, you can create this fella. Now, if you go for, that's L1. If you go for the second one, you're going to have to call it a different letter. The mistake people make is calling them both T and then weird things happen. So I'm calling it P of S. And what do I get? Well, the first one, I'm going to get S plus 4. And for the middle one, I'm going to get 3S, take away 6. And then for the last one, I'm going to get negative 7S, add 11. And now you can start the question. I can look at them right away and tell you they're not parallel. Would you agree the numbers just don't match? Right, 1 and 1, negative 2 and 3, and negative 3 and negative 7. So that I did in my head. Then you're going to have to pick two equations, those two, set them equal to each other, see if you can solve them. If you can solve them, t equals 2, say, plug it in here. S is 5, plug it in here. If the two answers match, you have an intersection. If the two answers do not match, then you just have skewed. But time got the better of us, so last name and bye-bye. I'll hang about for any questions you might have.